Hi, everyone. My name is Julie Q, and I spend a lot of time working with databases. Most of you, as Mary mentioned, might have run across the issue that I'm going to talk about today, which is that at some point, we all need to edit data in production. And there's a lot of ways that we can go about doing this editing, some of which are a little bit better than others. And today, I'm going to share with you the evolution of processes that I've been able to help develop at my company. Hopefully, the strategies that I'm about to share will also make editing production data safer at your organization, too. So a little bit about me. I'm an engineering manager at Spring. For those of you who haven't heard of Spring before, it's not just a Java framework. Spring is also a fashion e-commerce marketplace that integrates with thousands of different brands. At Spring, I lead the catalog team, which is the engineering team that builds out our product catalog. So this means that I spend a lot of time thinking about things like, how does data get ingested into our system? And over the last few years, more often than I'd probably like to admit, I've found myself behind the SQL prompt, needing to make edits to the production data. And after being in this situation a couple of times, I started to ask myself why. We're all told that directly editing data in production is really bad practice. So why are we all doing it anyways? Well, for me, the first reason is often that the internal tools that I needed are just not available. I would have used a better method, but it doesn't exist. The second is that I ran into an edge case. So sometimes we actually do take the time to prioritize building out a user interface, but it doesn't allow us to do all the things that we want to do or need it to be able to do. And lastly, sometimes we need to make a time-sensitive change, and jumping behind the SQL prompt is often just the fastest and easiest solution. It's really easy to just get behind the SQL prompt and execute a query. And usually, if we think about it, there's not really that much of a problem with it either. So for example, let's say I want to update the products table and rename the first product in the table to be named Julie's product. So I go ahead and I write a query like this in SQL, and before running it, I would always get a coworker to look over my shoulder and spot check me. But let's just say this time it's Friday night, hypothetically. And someone on the marketing team comes up to me and says, Julie, I need you to make this change. We promised the brand we would do it before Monday, and if you don't, they're going to pull themselves off of our platform, and they're one of our highest-selling brands. So of course, I go ahead and I write the query, and when I'm done, I look around me and I realize all the engineers have already left for the weekend. So at this point, I could Slack someone, but I don't really want to bother anyone. And I'm thinking to myself, I've been on the catalog team forever. I've ran queries similar to this a million times before. What is the worst thing that's going to happen? So I go ahead, I run this query, and at this point, I decide, I'm going to go grab a drink of water, Slack the marketing team, let them know I ran it, come back, get my bags ready, and then I look down at my laptop and realize this is what I actually ran. And for those of you who aren't familiar with SQL, the rest of the audience is laughing, probably because they know that I've just accidentally updated every single product in our database to be named Julie's product. And based off of the laughter in the room here, I'm guessing that some of us are maybe laughing or even cringing because we actually have disaster stories similar to the situation that I just described. And the key here is that these mistakes don't happen because we're all bad engineers. They happen because mistakes happen. And having the ability to make any edit that you want sets you up to make this kind of mistake. So today, I want to talk to you about some strategies to make editing data safer at your organization. Today, we're going to talk through 5 different strategies. These include strategies for maintaining a raw SQL spreadsheet, running scripts locally from your laptop, running scripts on an existing server, using a task runner, and building out a fully fledged script runner service. We'll walk through the strategies in order of the amount of upfront effort it takes for the strategy to be implemented at your organization. And we'll also talk about the benefits that you receive in exchange for this effort. For each strategy, we'll talk about 3 things: how this strategy works and an example of how to implement it, what's great about the strategy, and also what's not so great. The examples we're going to talk through today will involve using a Python stack and a SQL database, but these strategies can really work for any stack of your choice. So let's dive in. The first strategy we're going to talk about is pretty simple. It doesn't require any new code to be written or infrastructure to be built. Rather, it's simply developing a process for making sure that we get spot checked when we're making edits to production. So what does this process look like? Well, let's go back to the query that I had intended to run for the marketing team. I want to update the product with ID 1 to be named Julie's product. And what I did a few slides ago was I just went ahead and ran this query without any supervision, which we all saw was a pretty dangerous situation to be in. So what we started doing at my company is we started maintaining a Google spreadsheet to record manual SQL queries against production. This Google spreadsheet lets us collaborate and review each other's queries before they're executed. So this gave us a checklist of what actually needs to be done before running a query against production. Here's what that checklist looks like. So the first step is I'm going to add a record to this spreadsheet. Some information I fill out include my name, the date, a description, the query I actually want to run, as well as jotting down the reviewer. So the reviewer would look at my query and then either approve it or request changes. Similar to code reviews, after you go back a couple of back and forths, the next step is for the reviewer to actually approve the query. And once you've gotten those 2 thumbs up, the last step is go ahead and run the query. In this step, we ask everyone to do their manual edits inside a transaction. So that way, if they notice that they made a mistake halfway through, it's really easy to roll back. So what's great about this system? Well, the first is that it's really easy to implement and get up and running. You can do this before the conference even ends today. All it really takes is making a spreadsheet and sending an email to your team. But the effects are really powerful. And this is because having this spreadsheet gave us an audit trail. So after we implemented this process, we went from having ad hoc queries that we hoped people were getting checked to having a log of everything that was being run against production and who had looked at it. This audit trail not only gave us information about who was running the queries, what they were running, but also why they were running these queries. And this has led us to have a lot of discussions about areas where we should maybe really be investing in internal tools or just overhauling and rebuilding a system entirely. And lastly, this system helps to promote the right behaviors. So it helps because it doesn't only encourage everyone to be careful, it also actually teaches engineers what are the right things to do. So if we think about the journey that we'll go on in this talk, right now we have a strategy that gives us the benefit of data editing. It requires very little upfront investment, and we've also implemented a manual version of a code review process and an audit trail. This is great because at your average startup, raw SQL edits are probably never going to completely go away. We still use this spreadsheet to this day. But this process makes it so that we're empowering engineers to avoid making mistakes and making sure that they're getting spot checked. And introducing this process also makes it just slightly more painful for people to think about how to run these SQL queries, that they're encouraged to build better tools. So what are some things that we're not getting with this system? Well, the first is that it can still be easy to make mistakes. We're assuming that people are copying and pasting queries from the spreadsheet directly to the SQL prompt, but that might not be true. And even so, errors can happen. This audit trail is also being maintained manually, so that also opens up some room for error. After all, there's really nothing preventing someone from running an unchecked query. And lastly, while it's relatively easy to update, say, one product to Julie's product, it can be difficult to execute long and complex logic with SQL. if your query takes a really long time to run, it's going to time out. So for example, let's go back to this query. What if that Friday, the marketing team hadn't asked me to update just this one product? What if instead they said, hey, Julie, there's a store on the Spring platform. It's called Julie's Store, and inside that store, there's a bunch of active products that don't currently have a name. Can you update all of those products to be named Julie's product? We can now see how these queries can become complex really quickly, and we want something a little bit better than just raw SQL. So let's talk about our next strategy, which is going to help us run these long and complex queries. So our next strategy is to write scripts and run them locally on our machines. And here's what that process looks like. To run the scripts, we'll start by writing it. We would convert the SQL logic we would have wanted to write to code in the programming language of your choice. I usually, when I'm writing my scripts, like to add an argument parser, so that makes it so that my scripts can be reusable in the future, especially if I plan to use this logic again. Say, I want to rename product 2 to Julie's other product. And then next, we're going to form a connection to the production database. You can do this using VPN or SSH gateway. And lastly, go ahead and just run the script from your terminal. In Python, this is what my command looks like. And I often like to write my scripts in such a way that I can just add a dry run flag. So that way I can preview the results before actually committing changes to production. So what do we like about this strategy? Well, the first thing is that scripts, unlike SQL, can be reused. So you can write the script just once and then just add in different arguments to run it again in the future. Additionally, if you need to manipulate the outputs of the script, it's really easy to just say, pipe it into a text file. And lastly, writing a script gives you access to the rest of the code in your repository. So you can import functions from your common code or reuse logic that you've already written before. And looking at our journey now, we now have a strategy that gives us both the ability to edit and the ability to execute, make edits with somewhat complex logic. At this point, we haven't needed to set up any infrastructure. So the upfront investment is still relatively low, though a bit higher than just running queries with SQL. There's some things we still don't get with this process, though. The first is that we don't have code review being strictly enforced. So someone can just write a script and connect to the database from their laptop and run it without any form of code review. The outputs of the script are also only available on the user's machine, and they're going to go away as soon as we exit out of the terminal. And lastly, we could run into network connectivity issues. The script's going to stop running if, say, the internet dies out, or the user just closes their computer. Which kind of begs the question, how do we go about running really long scripts? For example, what if I wanted to run this query many times? In fact, at Spring, we currently have over 50 million products in our database, each of which have many different attributes and variants. What if I wanted to update a field on all 50 million products? This is actually a common situation that I run into on projects for the catalog team. And I've often had to run migrations on the entire products table. When I first started working at Spring, what I would do is I would just come into work really, really early and plug in my laptop and let the script run for the day. And this was until one day I was sitting there waiting all day, and by around like 7 or 8 p.m., only about 25% of the products table had been processed. So I talked to my manager at the time about workaround strategies. And we sat there thinking, wouldn't it be nice if I just had a computer that was already set up with all the information I needed, and it had all the configs that I had on my laptop, except this computer was just on all the time? Well, conveniently, we have several EC2 instances to do that. After all, that is how our websites stay up and running all the time. So the next strategy we're going to talk about is how to run scripts on an existing server. And here's how this will work. So similar to running scripts locally, I would start by writing my migration scripts. Because we're running the script on a server, the next step is actually to get the script onto the server. There's a lot of different strategies for doing this. You could deploy or fetch a copy of the code. You can upload or transfer the script. We often compile code before deploying to an application. So what I would often do is just copy the script onto the remote server using SCP. And I would often use Jenkins as the server for which to run my scripts on, because it's a server that we run automated tasks on, like our deployments. And after the code exists on the server, the last step is just to SSH in and then run the script inside a session. In general, this method of running scripts on Jenkins has worked really well for me, and it's gotten me through a lot of really major projects. That was until one day, this message showed up in our engineering Slack channel. Our on-call engineer, Maya, happened to notice that Jenkins was down. And so she pinged our DevOps lead, Justin, to check if it was down. And because I'm a really responsible engineer, of course, I also check. And I confirm, yeah, Justin, it's down. You should really look into that. And then I went back to doing my work, and about a minute or two later, I had a realization. As most of you could have guessed, I think I shut down Jenkins. And my hunch was right. It turns out that Jenkins was down because the script that I was running on it was using up all of the CPU, and as a result, none of the other engineers could deploy anything. It was a pretty easy fix, though. All Maya had to do was just reboot the instance to bring Jenkins back up, which means that running queries on an existing server is still a pretty good strategy for running long scripts, especially if you just monitored it a little bit more closely than I did, and a little downtime isn't the worst thing. But it was a lesson learned for me that we should think about putting in better infrastructure. Before we talk about improvements, let's talk about what's great about running scripts from a server. So the main thing is that you can now run long scripts, or really any scripts, without having to worry about your computer being on. You can run your scripts inside a session and then just come back and check on it later. Also, because we're running our scripts on a remote server, we now have the benefit of a much more reliable network connection. And lastly, you're getting all of these benefits without having to actually put in any new infrastructure. So when we look at this strategy in comparison to the others that we've seen, the main benefit that we have now is that we can run really long scripts without worrying about our laptop shutting off. The strategy has relatively low investment costs. There's some DevOps configuration involved, but it's still a pretty easy system to rely on. What doesn't this strategy get us, though? Well, as we can see, the strategy of running scripts can affect the resources on that server. In my case, we used up too much CPU, but you can also run into cases where you end up consuming too much memory. Second, the need to copy the script onto the remote server, SSH into that server, start a session, and then make sure that session is running just to run a script, it's really not the most user-friendly experience, and it opens up a lot of room for error. And lastly, we still don't have a persistent audit trail. Sure, there's logs available inside the session, but they're probably going to get lost as soon as the session ends, and most likely only the engineer that started it actually has access. So we can do better. Let's talk about a strategy next that's more user-friendly for our engineers and also gives us a persistent audit trail. The next strategy we're going to discuss is using a task runner. So a task runner is something that lets us automate the tasks that are associated with running the script. So this includes things like actually SSHing into a server or setting up a virtual environment in the case of Python, getting a copy of the code. All those repetitive things that I was doing before, we're going to do using a task runner. And best of all, logging's built in. So the way that we did it was we set up a task runner on Jenkins because we wanted to use Jenkins as our continuous integration server for builds and deployments. Jenkins also lets you write code and register arbitrary tasks. And the Jenkins build page provided us with a free user interface. So similar to the last strategy, we're going to head and write the script. We're going to get the script reviewed, tested, and merged. And then lastly now, instead of SSHing into the server to run the script, all we have to do is use the Jenkins interface and input arguments. So to run a script, you would go to a project, type in the file path of the script you want to run, select the arguments you want to use, and then click Build. And Jenkins takes care of all of the annoying things that we had to do before, like setting up that virtual environment, connecting to the remote database, and running the script with all the arguments you provided. And the best of all, in this case, you can just sit there and watch the output happen. This strategy is great because it's the first one we've seen that gives us a persistent audit log. So these logs make it easier to monitor the progress of a script, which is really useful for long scripts, as well as lets us trace back what had happened. Because the first step of our task runner is to actually fetch the latest version of master, all the code being merged onto the task runner needs to be code reviewed and merged. So this means that we're now able to enforce those practices and provide the ability also to write automated tests before scripts are run. And lastly, we can now run our scripts from a user interface, as opposed to having to SSH into a server, which minimizes room for error. And we've come pretty far on our journey now. At this point, we have a process for code review, for running automated tests, for having an audit trail, and we also have a user interface. Setting up a task runner did take a bit of time, but when I think about the amount of time that our team of 50 engineers has been able to save because we don't need to do things like manually copy code onto a remote server and make sure it's the right version, or figure out how to correct our mistakes when we have absolutely no logs to look at. The upfront investment kind of seems pretty worth it. There's still some reasons, though, that this isn't exactly what we want. And the reason is that, first off, inputting command line arguments every time you want to run a script, it's kind of annoying, and it also makes managing credentials a little bit hard. So this is particularly true if you have a lot of credentials. For us, this was the main driver to look into better solutions. As our company grew, after the task runner launched, I found that one engineer was still running really long scripts by copying them onto an existing server. And this was simply because the script he needed to run had over 30 credentials. So it was just easier to put them on a text file on a server somewhere, and then pipe them into the script whenever he had to run it. There's also not a clear separation of environment here. So because we're just piping in command line arguments, it's easy to accidentally say, use credentials for production and then run them on the dev database. So that's not great. And lastly, there is no system in place for us to verify the arguments being passed in. So for example, what if I'm writing a script and I want to update product 1 to Julie's product? No one's there to making sure that I'm actually updating product 1 instead of product 2, or say spelling Julie correctly. So all of these really annoying problems that I was having, they really got me thinking. We have all these problems we're dealing with: configuration management, logging, separating environment. Haven't we solved all of these problems before? After all of our existing applications do this. So why had I been trying to reinvent the wheel instead of just building something with the tools that I had already been working with? So I did. And I decided to use our existing tools to build an application to run scripts on, our own internal script runner service. And this would be architected like the rest of our Python applications. So here's what that architecture looks like. We had an application server that was set up for each environment to run it. Each server had access to credentials that were stored in Hiera, which were common to all of the EC2 instances in the environment. The application was then set up to connect to the database in its respective environment. And as far as the user is concerned, the steps for running the script were really similar to that of the task runner, except for one small change. So the first part here is the user is going to write the script, get it code review, tested, and merged as before. But lastly, the key difference here is that the user no longer needs to input a series of arguments. All they have to do is just pick the environment they want to run the script in, and they'll have all of the credentials that they need. So here's what it looks like to run a script with this UI. The user is going to go to the user interface, type in the file path of the script they want to run, select the environment, and then just click Build. And all of the command line arguments that we had to manually enter before, they're just going to be available as environment arguments on the script runner server. Which brings us to some of the key benefits of the script runner service. The first of which being centralized configuration management. So we now have a system for using credentials in our script that is a lot more organized than just selecting a bunch of command line arguments. The second is that this strategy allowed us to maintain clear separation of environments. And lastly, the system is by far the most user-friendly of all the strategies that we've seen. The amazing thing, though, about the script runner service is that it doesn't have to stop there. There's even more that we can do. For example, if there were several engineers who needed to run scripts at the same time, we can just parallelize and scale our instances. If we want to preview the effects of our scripts on the database before committing changes, we can also build in that preview mode functionality. So this would prompt people to realize if they were passing in the wrong argument or spelling something wrong, perhaps. And in the end, it's really up to you to customize your own version of script runner. So we've seen today a spectrum of tools that you can use for editing production data. So some of you might be wondering now, what strategy should I use? Well, ultimately, that depends on the needs of your team and your willingness to invest in the upfront cost of building the tool. If your team is small, then speed might be really important, and making mistakes once in a while might not be the worst thing. In that case, running edits and simply using raw SQL or local scripts from the command line might be enough and might be the best strategy for you. But for larger teams, benefits like logging and auditing can be really important. You can't have 50 engineers jumping into a Google spreadsheet every single time someone wants to run a SQL query in production. And you might also want to have a more centralized way to manage configs because there's just too many otherwise. In that case, building out a script runner service might make sense for your needs. But the key here is that as you think about growing fast and hiring your teams and building out the best engineering teams possible, make sure that you're also thinking about upgrading the infrastructure and internal tools that are needed to support them and allow them to do their best work. Which brings me to some of the key learnings that I had in the process of developing tools for running scripts. Which is that when you're building tools for your team, it's important to not only think about safety, but also think about speed and usability. After all, that's why we're all getting behind the SQL prompt anyways. It's not because we don't know it's the wrong thing to do. And in the same way that it's important to think about the end user when building out your consumer applications, it's also important to think about making something usable for your engineers. After all, engineers are also people. And on the flip side, a lot of times we'll find ourselves saying, looking at something and just be like, this is not ideal. I really shouldn't do this. And then 2 minutes later, you'll turn around and then just be doing that thing anyways. You should really invest the effort to stop doing that early on. Ideally, before you change the names of 50 million products to Julie's product. Thank you.